Hello and welcome to another free code session. My name is Jason Bach. I added in the continuing story of my setup, I added a USB laptop that I used to use with my USB screen that I used to use with my laptop and plug that into my computer. So now I've got that below me so I can actually see the time and the recording as it's going on. It was weird because when I pulled it down onto this screen, the camera view moved over, so it looked like I was getting chopped off. But now that I'm running it, it's fine. I don't know. It's all the fun of a new system. From the last episode, I was doing some benchmarking stuff and found out that the event generation seems like it's really taking a fair amount of time, especially during compilation. So I changed the little stopwatch timings that I'm getting so I can get a little bit more information that's helpful. I also changed it so that I'm doing like the top 10 of the slowest and the fastest and so on. What's ending up that I'm seeing is the generation time actually, even for like, I don't know why configuration's taking so much. It doesn't seem long to compile relative. I mean, it doesn't even show up for the slowest emit times. That's what I'm calling compilation. And actually what I could probably do is put in, no, actually, I think, I remember right, if I come back into the code here, if I do, where is that? Generate, yeah, so I have this time structure now. We capture the generation time, and then if we don't have any diagnostics, then we immediately go to that. So the compilation before is already done. And that usually is going to be really, really fast because the code is just an attribute that says rock create, and that's about it. So that first compilation is fast, and the generation, and then the actual emit of the assembly. What we have here for the slowest generation times is, again, configuration. I'm not sure why. We're going to have to look at that in a different way. But all of these are the ones that have that base interface type that has all these events. And as I showed in the last episode, that seemed to be causing a lot of the problems because if I commented that out, they all disappeared. So they also, and what's interesting to notice too is that the generation time actually is not too bad. Well, I mean, relative. Like the fastest generation times, we're talking like 8 or 9 milliseconds. And I'd love to get that even faster, but I think that's and again, this is just pure code to run the generator when you're dealing with environments like Visual Studio or even just the command line, in the command line compiler, when you do .NET build, who knows what else is in play? I mean, you can figure it out, but I don't know. But I imagine there's other things to keep in mind. That said, it's nice to know that to create a mock for this is taking about 9 milliseconds. The slowest emit times are taking like 60 milliseconds, which again, I would like it to be smaller than that. I'm sorry, generation times would be, this one's, 150 milliseconds, if I'm doing my math right. So I'd like to get those down. These should all go down once I have the events handled better. And I think I have an idea to do that. So let's get into what that actually is. And the best way to do it is show a code example. So what I played with and what I came up with is to kind of change things around with the base types first. So, and I'm calling these tests here just because I wanted to have this in my CS file such that it doesn't collide with what's currently there, and then I'll go back and change it. So I'll move these two things down to the bottom. The raise event thing is the actual most important one, as you'll see in a moment. And then the two adornment types that I have, I'll create interfaces for them. I thought of maybe putting the callback up here, and that was something I was going to look at is, no, not there. Not there either. Let's go into rocks itself. I think it was the handler types. So we have a handler, and that also doesn't do the delegate. That is a callback here. This one though, okay, I am mistaken. It actually does derive from this. Okay. So maybe what I could do is actually put that here. And then, well, actually, it would be literally just taking these, putting them there, and taking that because I would like them ordered, and we don't have that anymore, and we get rid of this. Okay, so we will have that base type, and I think though, see, that's the thing is we have. Okay, I'm actually mistaken again. This is deriving from the base type, which just has those two. So you know what? Let's keep it because I know what I have works. And using what you have that works is better. There, okay. So I'll have these two interface types, and the two adornments that I have, they will implement one or the other, okay? So that should be pretty quick. That really shouldn't change much, hopefully. The custom type, though, what I'm going to do is for each mock that I'm creating, I'm going to create this special interface. And this basically says, hey, for any adornment that I create, it's got to be of this type. They're all going to derive from this, and we're going to make sure that's of the specific type. And the reason we do this is because now I'm going to generate, instead of just having, if you see here in the events, when I come up here, I don't actually create a class for the adornments. I basically say it's going to be this whole thing equals, and then I return that. I'll create a separate type for each one, and they will also derive from this. Okay. And then from that on, like in this case, this type would now take the place of this. And, you know, because we could say new here, all of that will still work. Okay, so it's just that thing is going to change. And then the key is for the events is I'm only going to generate one of the raises for each event as long as the adornments is of that specific interface type that I generate up here. And so that constricts it to just be, or constrains it to being just of the adornments for this particular mock. And so I won't have the case where I could potentially have the extensions available on other mocks. And that should work. And so I did another one down here to do that. And as you can see here, if I do raise my event, I still get callback. I still get expected count, but I do not get raise rock thrown. Same thing down here. That doesn't get raise my event. The advantage of this is that, again, I don't have to create all of these for every single handler that I find. I only have to create an event extension per event and then constrain it accordingly. So the disadvantage of this is that I'm going to be creating this separate type, but doing this stopwatch analysis, I don't think that's really going to hurt in terms of performance a lot. I think maybe it will make the emit times go up just slightly, but definitely lower than what you're seeing here. So I'm hoping that kind of offsets. Now, of course, this is also going to break a lot of unit tests, but if this all works so that the integration tests and code generation tests work, then I'll just go back off camera and update the unit tests. And then I'll look for more areas to increase performance. I'm also going to put this comment on a lot of the types. I think I went back and forth on this before, but I am going to do this because I want to be very clear to say, don't use these. These are purely for the code generation purposes, and it's not intended for you to use directly. Okay, so how do we do this? Well, first thing we want to do is go into adornments, and we're going to take a base approach. So I'm going to take all these. Wait, what did I just do? No, I want to copy these. I do not want to paste them or cut them. So I will take test adornments and I will make it adornments and make sure we got that. It's barking because I don't have XML comments. That's what I'm trying to say. So defines the interface for all adornments. And I will come back and clean all these up later. So what do I have for add raise event? And I think I can do raise event information. Yeah, Oh, that's right. I think I ran into a case where it's like, don't put raise event. It did do raise event information. That's what you want to do. So we're going to have to change those, but whatever. Because it collided with raise event, which I think is a keyword, and maybe VB. I don't know. It's like, who cares? Who gives a crap? Okay. So now this defines the interface for adornments that have a callback. And then we'll do that here for have a callback and a return value. So what is the comment here is that. We'll bring that back up here. And then for a return value, we'll do that. And we'll grab that. Oh, you don't have a type param. Okay, so now adornments, if I remember right, will derive from adornments of tHandler and tCallback, but we're going to have to put one more in, right? Yes. So we're going to have tAdornments. So yeah, this is technically breaking things, but it's not a breaking change because you shouldn't actually be using these. And then that's going to change some other things. So our tAdornments is adornments of... Yeah, I didn't keep... That's actually something I didn't... Oops. Oh boy. Crap. Yeah, well... Okay, I'm worried about the handler thing. That's what I'm really worried about. Because I didn't anticipate that. Oh, I just flat out forgot about it. And actually here, we want this to be tAdornments. And that's going to screw things up because that's okay. I think I can put it back up here. tHandler. I should have looked. And then it's that. Must have the same type parameter names in the same order. Partial declaration of adornments must have the same type parameter names in the same. Have inconsistent constraints for. I'm not sure what this is barking about. tAdornments, tHandler, and tCallback. I really don't know what this is. Partial. It's what? I really don't know what this is complaining about. Oh, okay. It just goes away. Fine. I'm not sure. Wait, that's okay. So now we have tHandler. That goes away. Ambiguity between adornments. What? Oh, is it oh, maybe it's because that maybe? Possibly? Is this? No, it doesn't. Yeah, it doesn't derive from that. I don't understand. Well, let's just keep going. This could be actually now. No. Isn't there inherit doc? Yeah. And then you can say that here. And this one, though, we need this to be tAdornments. Now, if we fix this one up, tHandler, this needs tAdornments. Okay. And type parameter. This episode is going to be all just about getting this all to work. Okay. So this now needs to derive from adornments of handler callback and tReturn value, where it's tReturn value. And now we need this to be tAdornments. Nope. Ah, crap. Did I never test this? Cannot, yeah, shoot. But No, I could still say there. But now, oh boy. Ah, crap. This has just turned into a huge mess. That's kind of weird because this does, well, it doesn't derive from this. But T adornments, because of our constraint, we can say it is going to be of that. So that would work. Thankfully, we don't have to generate this. And now you're barking because why? The type parent, you didn't bark on any of this over here. Cannot convert. What am I missing? A brain? Yeah, probably. I really don't understand what's going on here. But you're going to complain that I'm not. Now you're going to complain about this. Fine. So, shoot. I'm actually kind of mad because I already went through all of this and it should have. Can I just say class here? No. Why? Can you all just shut up? Okay, now why are you complaining? The type T adornments, yes. Okay. A type used as a constraint must be an interface, a non-seal class, or a type parameter. Why? T adornments works just fine here. Oh, God. Why is this complaining? This is, oh. Was it because I was missing all that? And I totally forgot that they needed to be unsealed. It's not going to fix this. Yeah, at least it fixes that. I'm going to have to look at this a little bit more in detail and make sure that this works. Because sure, I can cast it, and I think it should all just be fine. Do I really derive from that, though? Is that actually true? I'm not sure. I don't know if the types, I'm blanking right now to go, in the type system, would that actually work? So I'm going to do a little bit of research off camera, and then in the next episode, I will either move on with this approach or have to come up with something else. So I hope I can, because I think this will help with generating all those events, event extension methods, but maybe it won't. We'll see. So hopefully in the next episode, I have some good news. Thank you all for watching. Leave comments and questions below. See you in the next episode.